This panorama was taken during the winter season on Mars's southern hemisphere. This is the time of year when Mars is farthest from the Sun, so there is much less dust storm and dust devil activity than at other times of the year. The view reveals a tremendous amount of detail in the location around a small hill. Many dark, porous, textured volcanic rocks can be seen around the rover, including many on the hill. Two rocks to the right of the center, brighter and smoother looking in this image, are thought to be meteorites. On the right are Husband Hill on the horizon, rippled sand dune filled near the base of that hill, and lighter toned home plate below the dunes. Left of center, tracks and a trench dug by the rover's right front wheel have exposed bright underlying material. This bright material is evidence of sulfur-rich salty minerals in the subsurface, which may provide clues about the watery past of this part of Gusev crater. In addition to acquiring this spectacular panorama, the rover team also acquired significant new assessments of the elemental chemistry and mineralogy of rocks and soil targets within reach of the rover's arm. The team then drove to a nearby spot on the hill to access different rock and soil samples. This view shows Utopia Planitia, a plain that fills one of three major basins in the northern hemisphere of Mars, Utopia, and has a diameter of 2050 miles. This plain is thought to have formed as the Utopia basin was filled by a mix of sediments, lavas, and volatile substances, those that vaporize easily such as nitrogen, carbon dioxide, hydrogen, and water, all transported across the Martian surface by water, wind, or other processes. Utopia Planitia is an intriguing and ice-rich region. Ice has been spotted lying both at and just below the surface and at greater depths, detected via observations of fresh craters and pits and by probing Mars's deeper layers using radar. Visible to the left and right of this scene are large, smooth patches of surface known as mantled deposits. These are thick layers of ice and dust-rich material that have made the surface smooth and were likely deposited as snow back when Mars's rotational axis was much more tilted than it is today. Towards the center of the image, the two largest impact craters visible here are surrounded by double-layered mounds of material. A similarly layered appearance is also visible in the deposits that have built up within the craters themselves and in the craters' thick rims. The second largest crater in the image, just below the left of center, showcases a texture known as brain terrain, where material has become deformed and warped in a concentric pattern that resembles the complex patterns and ridges found on the surface of the human brain. Brain terrain is associated with the icy material found near the boundary between Mars's northern plains and its southern highlands, a dichotomy located to the south-southwest, which is the upper left of this scene. Just to the right of the brain-textured crater is an especially dark-colored region, created as the ice-rich ground contracted and cracked at low temperatures. This formed polygonal patterns and fractures that subsequently captured dark dust blown across Mars by wind, leading to the dark appearance seen here. Additionally, scalloped depressions are omnipresent throughout this image. These have circular to elliptical shapes, depths of several tens of meters, and sizes varying from tens to thousands of meters across. These features are the result of ground ice either melting or turning to gas, which then causes the surface to weaken and collapse. Upon closer look, layered mantle deposits can also be seen in and around these scalloped depressions. This view from within Perseverance Valley on the inner slope of the western rim of Endurance Crater includes wheel tracks from Opportunity rover's descent of the valley. The rover wheel tracks are darker brown between two patches of bright bedrock receding toward the horizon in the right half of the scene. Perseverance Valley is a system of shallow troughs descending eastward about the length of 2 football fields from the crest of the crater rim to the floor of the crater. This panorama spans from northeast on the left to northwest on the right, including portions of the crater floor eastward in the left half and of the rim westward in the right half. Opportunity began descending Perseverance Valley as part of an investigation into how the valley formed. Ingenuity Mars helicopter recorded this video during its record flight as it covered a distance of 2,310 feet at a speed of 12 miles per hour. It was the Red Planet rotorcraft's longest and fastest flight at the time. The first frame of the clip shows the view about 1 second into the flight. After reaching an altitude of 33 feet, the helicopter heads southwest, accelerating to its 12 miles per hour maximum speed in less than 3 seconds. Ingenuity first flies over a group of sand ripples, then about halfway through the video, several rock fields. Finally, relatively flat and featureless terrain appears below, making a good landing spot. Ingenuity's navigation camera had been programmed to deactivate whenever the rotorcraft was within 3 feet of the surface. This helped ensure any dust kicked up during takeoff and landing didn't interfere with the navigation system as it tracked features on the ground. This hillside with thousands of wafer-thin layers of rock have eroded into sheets of rock that jut out from the rock wall in gravity-defying ways. These thin slabs of rock projecting into the thin Martian air are less than 1 inch thick and show complex pattern of erosion that has taken place. If you were to view this picture taken today besides one taken 6,000 years ago, there would be few obvious differences. That is because these rocks are eroding just about half an inch per 1,000 years. So to erode a foot of rock seen here could require 24,000 years under current environmental conditions. Such low rates of erosion is caused by the environmental conditions on the surface of Mars. The only erosive forces active at this site are winds laden with dust, thermal contraction and expansion, bombardment by high-energy cosmic radiation, and possibly some chemical weathering. None of these forces can work quickly in the thin, cold atmosphere of Mars, which is devoid of many chemically active molecules. Under present conditions measured directly by Curiosity rover, erosion of half an inch per 1,000 years seems almost too good to be true. Nonetheless, these rates of erosion suggest that the spectacular geological features observed in Gale crater have not changed much in hundreds of thousands and even millions of years. The very slow pace of change on the surface of Mars is power evidence that Mars's surface is very ancient. In fact, it is far older than the surface of the Earth, which is far more rapidly eroded and then replaced by plate tectonic forces which force sedimentary rocks up into large mountain chains. Curiosity Mars rover took this image as it looked back at a dune that the rover drove across. The rover had driven over the dune 3 days earlier while making its way towards Mount Sharp. For scale, the distance between the parallel wheel tracks is about 9 feet and the dune is about 3 feet tall. The view here is looking eastward. This panorama shows the Martian terrain and an outcrop in the middle distance where a pale rock unit meets a dark rock unit above it. The outcrop exposing the contact area is in the eastern portion of the area called Logan Pass. The wind-blown ripples and the steep ground where ripples are lacking are both poor terrain for Curiosity Mars rover to cross. This observation helped the scientists evaluate routes for driving to that geological area where the two rock units meet. The rover team subsequently chose to approach a different site where the pale and darker rock units are in contact with each other. That alternative site is in the northern portion of Logan Pass area outside of this scene. Sand dunes trapped in an impact crater in Noachis Terra on Mars are seen in this view. Dunes and sand ripples of various shapes and sizes display the natural beauty created by physical processes here. The area covered in the image is about 6/10 of a mile across. Sand dunes are among the most widespread wind-formed features on Mars. Their distribution and shapes are affected by changes in wind direction and wind strength. Patterns of dune erosion and deposition provide insight into the sedimentary history of the surrounding terrain.